Let's consider this example where in part A here we have a coin landing on heads for event A, and event B would be a coin landing on tails. So this would be two disjoint events because you couldn't have any events that occur in both sets. For instance, you couldn't have a coin that lands on both heads and tails at the same time. So these would be disjoint. Here in example B, we have two sets. One is the set 1, 2, 3, 4, and another is the set 2, 3, 5, 6, 7. Now I notice that there are some elements. For instance, 2 is in both sets, 3 is in both sets. So because these two sets contain elements in common, they're not disjoint. In example C, we have the event A being a person plays soccer and the event B being a person plays baseball. So we could have, for instance, an athlete that plays both soccer and baseball. And so these would also be events that are not disjoint. Looking at part D, the event A is the event of rolling an even number on a six-sided fair die, and the event B is the event of rolling an odd number on a six-sided fair die. Again, these would be two events that have no elements in common. So for instance, A here would consist of only even numbers, 2, 4, and 6. And event B here would consist of only odd numbers, 1, 3, and 5. Since they have no elements in common, these are disjoint. This example will use the addition rule. Let P of E, probability of event E, equal to 0.11. P of F, the probability of event F, is equal to 0.78. The probability of the event G is 0.56. The probability of events F and G occurring at the same time will be 0.42. And then here events E and F are disjoint. What does that mean? Well, let's think of it this way. If P and F are disjoint events, then the probability that they both occur must equal to 0. Okay, so remember that disjoint events cannot occur at the same time. And so these two events have a 0 probability of occurring at the same time. Okay, so with part A, find the probability of F or G. Well, according to the addition rule, right, that will equal to the probability of event F plus the probability of event G, minus the probability of F and G. So according to the given probabilities up here, 0.78 was the probability of event F, 0.56 was the probability of event G, and then minus 0.42, the probability of F and G both occurring. So that gives me a total of 0.92 for the probability of F or G. Here looking at the probability of event E or F occurring. Here again, let's use our addition rule. So the probability of E plus the probability of F minus the probability of E and F. So that was 0.11 for probability of E, 0.78 for the probability of F. And again, up here, we've sort of mentioned already that the probability of E and F both occurring is 0, since they're disjoint. So that leaves us with the sum, 0.11 plus 0.78, leaves me with 0.89.